Hey guys, it's Mr. Fourth Dimension. Welcome to another episode of the Geo Project. So I'm going to take a look at what we were doing. I think it's time to test segment collision stuff. Right? We just got this looking like it was working last time, and now we want to give it a little more thorough testing. So this collided, right? If I remember correctly, where we left off. This was colliding, and it was giving us a hit location of 0.5, which is what we were expecting. So let me take out, well, let's see. I'm going to have a quick macro here, temporarily, because we might want all of this stuff to come back if we find another issue. But for now, we want to take it out, because we're going to see if things are working, and we want a nice, clean, output. Okay, so next what I want to do is I want to say, let's take these points and mess them around a little bit. So this first line here is the one we're casting, and the collision point between these two things, if I'm thinking this through correctly, should be at 3, 3, right? Because it takes 4 steps to move that way. Yeah, okay, so I'm thinking it's 3, 3 because it's 2 steps in the x direction to get halfway, and 2 steps in that y direction to get halfway, and if I increase both of these by 2, we would get 3, 3. So I'm going to try putting this on a very edge, see if we get a collision there. We got a hit right at 1, that's what we were hoping for. Now let's try the other way. We're going to get a hit at 0 if we put this at 3, 3. Ooh, it says a miss. Shouldn't that be a hit? If the other one was a hit, shouldn't that be a hit? Why would it record that as a miss? Might be a simple matter of rounding error. That should definitely be a hit, right? Yeah. So, there's a good chance that that's a rounding error issue, which suggests we might want a tiny bit of epsilon in the t situation. That's not necessarily something we want to bake into the low level here, but then again we said we can't keep this, we gotta clean all of this up. So, let's see if we can just fix this temporarily with, we'll call this the, what's the format I use for my other epsilons? Where I put it right in the function, right? Okay. So what we do now is we want to take this collision full function and give it a give it a little epsilon. I don't really like this. Maybe I want to provide the epsilon as a parameter actually. I don't know. Like I said, I gotta clean these functions up next anyway, so I think we'll just go with hard coding it in, and then we'll see what happens when we try to factor it out later. So the question is, if cast t, if that's less than or equal to 0, and okay, this has to be if t is greater than or equal to negative epsilon and less than or equal to positive epsilon. And this has to be if it's less than or equal to 0 and it's greater than, well, this can just be greater than epsilon maybe and less than epsilon. And greater than negative epsilon, or if cast t is greater than or equal to 1 and it is less than the epsilon. So that should fix our full version, and then this one just this, and this with a greater than and a less than, and we need to get another copy of the geo epsilon there. Okay, let's see if that does it. There we go. See, this -0 here is what's telling me maybe it's a rounding error, because maybe it's thinking that there's some very small piece out here. But I think that epsilon is a good rough solution for now, and maybe when we clean things up we can find some way to do this other than rotating even. That might have, maybe the rotation is the main problem, so when we try other methods maybe that'll fix it, and then we'll know that we have to use those for precision. Okay, let's test a few more configurations of these points. We want to make sure, let's put this back to the way it was, we want to make sure that if we flip it, it still works, so let's put the 5 there and cast towards the 3, 3. Now we should be hitting at the point 1. Miss. That is weird, because it's saying t equals 1, that shouldn't be a miss. Am I wrong? Am I wrong about this? Maybe I messed up the geo epsilon a little bit. If cast t is less than, oh, that should be 1 plus, right? It's not actually going to be less than the epsilon itself. And this should be 1 plus the epsilon, and this should be 1 plus the epsilon. There we go, hit at 1. And then if we extend this to 1 and then shrink the other side to 3, we should get another 0 there. Right. Cool. Let's pop these back to the way they were and try messing around with the other line. So we know that the collisions are happening at 3, so let's put this at an x of 3 and an x of 3, and we should get a collision at the same point still. At the 0.5, that is. Yeah. Cool. Now let's try lowering this side down to 3 and see if we still get a collision. Cool. And raising this side up should still give us a collision. That's a miss. That shouldn't be a miss. Why on earth would you calculate a miss there? Because you're getting the t equals 0.5 like you always do. It's a weird one. Okay, let's look at this again. If delta y is less than or equal to, so in this case we also might want to apply the epsilons here. Oops. Because it looks like it's not thinking that the delta y lands in the right spot. That's right, cast one is cast what if delta y equals, or if it, yeah, so this has to, that has to change, which is kind of annoying. If it's less than this minus the epsilon, if it's greater than this plus the epsilon, and then this is going to become another situation like that became. So we want to know if delta y is hitting the, so that's greater than or equal to top prime, and less than, well, in this case we already know top prime minus, what am I thinking? It's got to be less than, okay, right. Okay. So we don't actually need to do extras there, because this if up here is already testing that we're within the collision range, so we know there's a hit, and then if we're greater than or equal to the top prime, for that matter, don't we already know that? Yeah, we don't need to do these tests that I added, because those are redundant. We already know that those are true. So it's just a matter of if we're between this and the epsilon, which we already know we're within the negative and positive epsilons, right? So if we're between that 0 and 1, 0 and the negative epsilon, or 1 and the 1 plus the epsilon, then we know that that we want to count that as a tangential hit. Or if delta y is greater than or equal to top, right? Or if delta y is less than or equal to bottom, that's a tangential hit. Because we're already computing that there. And then the quick version, yep, we applied it there, so let's see if that's not gonna work. Huh? It's weird. It's weird that that's a miss, right? I'm not. If delta is less than. Okay, let's add that, subtract that. I just realized that what I did is I made the bound tighter. I made the window thinner with that epsilon instead of a little bit wider, which means I got these backwards too. Greater than or equal to this plus this, greater, less than that, greater. Okay, there we go. That makes more sense. And now we're getting a hit there. Alright, so that looks like we've probed it pretty well. Let's see, any other big ideas? I think that pretty thoroughly checks everything. So that means what we might want to do now is see if we can think about cleaning this up much. For example, right here, the very first thing that comes to mind is that we said we don't need to do both rotations on the x. So let's say we take that out, because we don't actually need to compute it. And another thing that occurred to me was, here we're doing the multiplication twice. I don't know if doing the multiplication twice is worse than just storing it, but the other big one was, look, we're doing this, and we're doing this thing where we subtract P1 to center it. But we're actually already centering stuff here. So what we want to do is actually rewrite these to not take a P1 anymore, and not do a centering. Right, just assume that P1 is going to be 0, 0. So what happens if this code assumes that P1 is 0, 0? So we want to do... we're taking care of this to do, but we need to do on retest vertical collisions. Now that P1 is defined as 0, 0. So we don't need to do that subtraction, because if it's zeros, it won't make any change to the number, right? Which means that vec is actually just a copy of P2, so we'll clean that up when we're done pulling out P1. That doesn't make any difference. That doesn't make any difference. That doesn't make any difference. Are there any other occurrences of P1 here? I don't think so. Now, let's go through and take all vecs and replace them with P2, since vec is just a copy of P2. P2 now is the vector we're casting along. Let's see, vec, there's one. Dot P2. I think that's all the vecs here. So we can get rid of this. That's better. Now we don't need top prime and bottom prime, so let's search for top prime, because it's just a copy of top. So that's better. We don't need bottom prime, because it's just a copy of bottom. And then we're not going to need x prime, because it's just a copy of x. Right, and that's the next version down. So there we go. That shortens it quite a bit. Much denser little function. Let's do the same kind of work down here. P1 be gone. Treat that as a 0. 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 And then we want to get rid of all of this copying of extra memory that we don't need to copy anymore. So that's a P2 and that's a P2. Top prime can just become top. Bottom prime can just become bottom. X prime can just become X. And there we go. That tightens things up quite a bit in this function as well. which is good. Let's make sure, okay, last thing we need to do to keep this working, the segment collision stuff and compiling, is we don't pass this explicit 0 anymore. And everything still works. We're still going to test that vertical line a little bit more rigorously, but the fact that it's working, well, the fact that it's working kind of suggests that it must still be right. Let's play with it for just another minute, because maybe we can confirm that it's working well enough to keep it that way. Because we were just casting directly on a vertical line, which might be a boundary case, but now we're getting, okay, that's a hit at 1, this should be a hit at 0.5. Right, and what we haven't even tested is like actual misses, but I think the actual misses are gonna work. Let's just put this at 2, 2, which should give us a T of 2 and therefore a miss. Yeah. Okay, I think that everything actually still works. So maybe we can skip testing the vertical line. Hope it's been a good time for you guys. See you guys next time.